What if a comet defied everything we thought we knew? What if a visitor from another star system arrived, only to put on a show so strange, so unpredictable, it left astronomers speechless? This isn't science fiction. This is the real-life cosmic mystery of Comet 3I-ATLAS. Get ready, because we're about to chase a celestial rebel across the cosmos and uncover why it's one of the most baffling objects we've ever seen. So, let's start at the beginning. The story begins on February 22nd, 2023. Astronomers using the ATLAS survey, that stands for Asteroid Terrestrial Impact Last Alert System, spotted something faint, a tiny speck of light moving against the backdrop of distant stars. At first, it looked like just another asteroid. But as they tracked its path, they realized something was profoundly different. This object wasn't in a nice, neat orbit around our sun. Its trajectory was a hyperbola, an open-ended path that meant only one thing. It came from interstellar space. It was a visitor from another star system, only the third such object ever confirmed. And so, it was named 3I-ATLAS, the third interstellar object. The excitement in the astronomical community was electric. The first interstellar visitor, Oumuamua, was a bizarre cigar-shaped rock that tumbled end over end. The second, 2I Borisov, looked and acted just like a regular comet from our own solar system. So, what would number 3 be like? The initial observations showed 3I-ATLAS was faint, but it had a small, fuzzy coma, a cloud of gas and dust, and a tiny tail. This meant it was a comet, releasing material as it got closer to the sun. But this was no ordinary comet. Its path was taking it on a journey that defied all expectations, a journey that would bring it incredibly close to both the sun and the Earth. This proximity was a golden opportunity. Scientists around the world pointed their telescopes, from massive ground-based observatories to the Hubble and James Webb space telescopes, ready to study this alien wanderer in unprecedented detail. They were hoping to unlock secrets about the star system it came from. What they found, however, was a cosmic enigma that raised more questions than answers. Almost as soon as the global observation campaign began, 3I-ATLAS started acting weird. Comets are supposed to get brighter as they approach the sun. The sun's heat vaporizes their ice, creating a larger, more reflective coma and tail. It's simple physics. But 3I-ATLAS did the opposite. Instead of brightening, it started to dim. Then it would brighten again, unexpectedly. Its light curve, the graph of its brightness over time, looked less like a smooth, predictable ramp and more like a chaotic, flickering flame. This wasn't just a minor fluctuation. It was a dramatic and erratic performance. What was going on? Why was this interstellar guest refusing to follow the rules? Then came the truly shocking observation. High-resolution images from telescopes like Hubble revealed that 3I-ATLAS wasn't a single solid object anymore. It was breaking apart. A chunk had detached from the main nucleus and was drifting away. This wasn't a gentle shedding of dust. It was a significant fragmentation event. And it happened far from the sun, at a distance where the sun's heat should have been relatively gentle. For comparison, comets from our own solar system typically only break apart when they get very close to the sun or a massive planet like Jupiter, where the intense heat and gravitational forces tear them to pieces. But 3I-ATLAS was falling apart way out in the cold, far beyond the orbit of Mars. It was as if a snowball was spontaneously shattering in a freezer. This bizarre, self-destructive behavior was unlike anything we had seen from a typical comet. Most comets are like dirty snowballs, mixtures of ice, rock, and dust that have been stable for billions of years. They follow a predictable pattern of activity. 3I-ATLAS, on the other hand, was acting like a celestial firecracker with a faulty fuse. It was fizzling, popping, and disintegrating right before our eyes. The speculation machine went into overdrive. Was this object just incredibly fragile? Was it made of some exotic type of ice that vaporizes at much lower temperatures than water ice? Or could it be something more? The behavior was so odd that some even whispered the same wild idea that was floated for Oumuamua. Could it be an artifact of extraterrestrial technology? Let's be clear, the alien technology hypothesis is always the very last resort in science, the explanation you turn to only after exhausting every single natural possibility. and astronomers are very good at finding natural possibilities. One leading theory for the strange behavior of 3IATLAS is that it's a nitrogen iceberg. Imagine a comet made not primarily of water ice but of frozen nitrogen, like the surface of Pluto or Neptune's moon Triton. Nitrogen ice turns directly into gas at extremely low temperatures, much colder than the temperatures needed to vaporize water ice. If 3IATLAS was a nitrogen-rich body, even the faint warmth of the distant sun could have been enough to trigger violent jets of gas, spinning the comet up so fast that it tore itself apart. This would explain both the early activity and the fragmentation. We've never seen a nitrogen comet before, so this would be a monumental discovery, telling us that other solar systems might build their comets very differently than our own. Another fascinating idea revolves around its origin story. Perhaps 3IATLAS isn't a comet at all, but a fragment of a larger, Pluto-like dwarf planet from another star system. Imagine a giant collision in that distant system, an impact that shattered a small icy world and sent this piece flying into interstellar space. Such a fragment would likely have a composition we're not used to seeing in comets. It might have pockets of supervolatile ices trapped beneath a crust, which, when heated even slightly, would erupt like geysers, causing the erratic brightness and eventual breakup. This would make 3IATLAS a messenger, carrying a sample of a shattered alien world right to our doorstep. By studying the chemical makeup of the gas and dust it released, we could essentially perform an autopsy on a piece of an exoplanet. The disintegration continued, more pieces broke off. What started as a single point of light evolved into a small swarm of mini comets, each with its own faint coma and tail, like a ghost ship, and its spectral fleet sailing through the solar system. The main nucleus, the heart of the comet, had vanished, completely disintegrated into a cloud of debris. The show was over, or was it? Even as a cloud of dust and gas, 3IATLAS had one last surprise. As this remnant cloud passed the sun, it experienced a massive, final outburst of activity. The cloud brightened dramatically, producing a huge, structured tail that was far larger and more complex than anything seen before. It seemed the final act of its solar passage was a last, powerful release of trapped gas and dust, a cosmic death rattle that was beautiful and baffling. So, what have we learned from this celestial rebel? First, 3IATLAS has shattered our simple definition of what a comet can be. It proved that interstellar objects aren't a monolith. They come in a wild variety of shapes, sizes, and compositions. Oumuamua was the weird rock, Borisov was the normal comet, and Atlas was the self-destructing enigma. This diversity tells us that the processes that form planets and comets in other star systems can be vastly different from our own. Each new interstellar visitor is like opening a new chapter in the grand story of galactic evolution. Second, the mystery of its composition is a tantalizing puzzle. Was it a nitrogen iceberg, a piece of a shattered exopluto? The data collected by telescopes like James Webb is still being analyzed. Scientists are meticulously sifting through the light spectra of its dusty remains, looking for the chemical fingerprints of different molecules. Finding evidence of high nitrogen or carbon monoxide content would strongly support the idea of a super-volatile body. This kind of detailed chemical analysis is our only way to truly understand where it came from and what it was made of. It's cosmic forensics on a grand scale. The story of 3IATLAS is a perfect example of how science works. An unexpected discovery leads to intense observation, which reveals bizarre behavior that challenges existing theories. This forces us to come up with new, creative ideas to explain what we're seeing. It's a process filled with excitement, confusion, and ultimately a deeper understanding of the universe. Imagine a chunk of rock and ice, born in a completely different solar system, hurled across the vast emptiness of space for millions, maybe billions of years, only to wander into our neighborhood. The excitement was palpable. Telescopes all over the world, including the mighty Hubble Space Telescope, swiveled to get a good look at our new guest. The excitement was palpable. Telescopes all over the world, including the mighty Hubble Space Telescope, swiveled to get a good look at our new guest. Initial observations suggested it was a fairly large comet, and as it approached our sun, everyone expected a spectacular show. But then, something strange happened. Instead of brightening, 3IATLAS started to fade. And not just a little bit, it was dimming rapidly. It was like watching a cosmic magic trick, a disappearing act on a grand scale. The comet was breaking apart. But why? What could cause a seasoned interstellar traveler to disintegrate so dramatically? This is where the real mystery begins. One of the leading theories is that 3IATLAS was spinning itself to death. Imagine an ice skater pulling their arms in to spin faster. As the comet got closer to the sun, the solar radiation would have heated its surface, causing jets of gas and dust to shoot out. If these jets weren't perfectly balanced, they could act like tiny rocket engines, pushing the comet to rotate faster and faster. Eventually, the centrifugal force could have become so strong that it literally tore the comet apart from the inside out. It's a violent end for such a long-traveled object. Another fascinating possibility involves pockets of super volatile ices. Think of it like a cosmic soda can. The comet might have contained frozen gases, like carbon monoxide or nitrogen, that turn into gas at incredibly low temperatures. As the 3IATLAS approached the sun, even the faint warmth of deep space could have been enough to trigger a chain reaction. These trapped gases could have erupted with explosive force, shattering the comet's fragile structure into a cloud of debris. It would be like a series of internal explosions, ripping the object to shreds. To figure out which theory holds water, scientists meticulously analyzed the data from our telescopes. They were essentially performing a cosmic autopsy from millions of miles away. By tracking the brightness, the color, and the trajectory of the fragments, they could piece together the timeline of the breakup. The Hubble Space Telescope provided stunningly detailed images, showing not one solid object, but a faint, elongated smear of dust and a few smaller, tumbling pieces. It confirmed the comet's demise. The speed of the disintegration was shocking. Within just a few weeks, a promising visitor became a ghostly trail. This rapid breakup suggests that 3IATLAS was incredibly fragile, perhaps more like a loosely packed snowball than a solid rock. This fragility has huge implications for how we understand interstellar objects. It tells us that what we see might just be the tip of the iceberg. The objects that survive the journey into our solar system might be the toughest ones. What about the countless other, more delicate visitors that break apart before we even get a chance to spot them? The demise of 3IATLAS suggests that our cosmic neighborhood might be littered with the faint, dusty remains of these failed interstellar messengers. To truly appreciate the significance of 3IATLAS, we need to look at its predecessors. First, there was Oumuamua in 2017. This object was bizarre, a weird elongated shape that accelerated away from the sun without any visible tail, defying our understanding of comets. Was it an alien probe? A new type of natural object? We still don't know for sure. Then came Comet 2I Borisov in 2019. It behaved much more like a traditional comet, with a clear tail of gas and dust, giving us our first real sample of the chemical composition of another solar system. Atlas fits into this family as the fragile one. While Oumuamua was the enigma and Borisov was the classic comet, Atlas showed us the vulnerability of these objects. Each visitor is like a different chapter in the same epic story, teaching us that interstellar objects come in all shapes, sizes, and compositions. There isn't a one-size-fits-all model. This diversity is incredible because it hints at the vast diversity of planetary systems out there. Just as our solar system has rocky planets, gas giants, and icy comets, other systems likely have their own unique mix of celestial bodies, and that's the real prize here. Studying these objects is like a form of interstellar archaeology. We can't travel to other stars yet, but we can study the pieces of their solar systems that come to us. By analyzing the light from these fragments, we can determine their chemical makeup. Are they rich in water? Do they contain organic molecules, the building blocks of life? The composition of 3IATLAS, even in its broken state, provides clues about the conditions in its home system. It helps us understand how planets form elsewhere in the galaxy. For instance, if we find a lot of water-rich comets coming from a particular direction in space, it might point us toward a region of the galaxy where water, and potentially life, is more common. This information is crucial for the search for extraterrestrial life. Instead of just looking for signals or habitable planets, we're now able to study tangible material from other star systems. Each interstellar object is a data point that refines our models of planetary formation and helps us narrow down where to look for life. The story of 3IATLAS, a story of spectacular failure, ironically brings us one step closer to answering the ultimate question. Are we alone? So what's next in this grand cosmic quest? The story of 3IATLAS highlights a critical need. We need more eyes on the sky. The Vera C. Rubin Observatory, currently under construction in Chile, will be a game-changer. It will scan the entire visible sky every few nights, creating the deepest, widest movie of the universe ever made. It's expected to discover dozens, maybe even hundreds, of new interstellar objects, giving us a much larger sample size to study. But just finding them isn't enough. The fleeting nature of 3IATLAS shows us that we need to be ready to act fast. That's where future missions, like the European Space Agency's Comet Interceptor, come in. This innovative mission will essentially park in space, waiting. When a new, pristine interstellar object is discovered, the mission will be deployed to fly by and study it up close before it has a chance to be altered by our sun or break apart. It's possible. While the main body has dissipated, some larger chunks might have survived. Finding them would be like finding a needle in a cosmic haystack. But with our improving technology, it's not entirely out of the question. Discovering a remnant of Atlas would give us a second chance to study this unique object. Ultimately, unraveling the secrets of these cosmic wanderers will require new technologies. We need telescopes that are more sensitive, spacecraft that are faster and more agile, and advanced AI to help us sift through the mountains of data to find these faint, fast-moving objects. Each discovery, even one that ends in a cosmic puff of smoke like 3IATLAS, pushes the boundaries of our knowledge and fuels our curiosity. These interstellar visitors are reminders that we are part of a vast, interconnected cosmos, a galaxy full of wonders just waiting to be discovered. The story of 3IATLAS isn't just about a comet that broke up. It's about the enduring human spirit of exploration and our relentless quest to understand our place in the universe. Thank you so much for joining me on this cosmic investigation. If you're fascinated by the mysteries of space, make sure to hit that like button and subscribe for more deep dives into the universe. Let me know in the comments what you think happened to 3IATLAS. Until next time, keep looking up.